In this first video I thought I would try and provide a recipe that would allow you to render standard glass and have an improved appearance. So as things stand, I've got default Bryce lighting, so I'll just reset the sky and show you that if you reset the sky, you need to make sure that the sun moon shadow, which is the global shadow intensity control, is set at 100. That's an important step because we're going to try and create quite a realistic looking render. And we've got material I'm going to use is from the material lab. It's one of the existing ones. So if you go to glasses and pick out this glass standard, we're not going to explore coloured materials yet. We're just looking at plain glass, and that's complicated enough in itself. Things to be aware of is that we have 100 in specularity. The specular colour for the highlight comes from this component here. So if I hold the Alt key down, click on the colour swatch, you can see it's fully white, and the size of this halo and the colour of it is also controlled by this specular halo colour, and if we check that, you'll see it's set up reasonably high. The thing about this is that this highlight comes about as a result of the specular output of the sun. So the sun has diffuse output and specular output. You'll notice that the diffusion value is set to 0 in this case, so there's no diffuse response, and the transparency is set to fully transparent. And the only reason this is invisible is because we have a refraction value here, and this refraction value controls how much the light rays, when they're traced through the surface, are bent, and this effect creates the illusion that we're looking at something that's glass, because the refraction is an important property of glass. The other thing, though you don't think it's there, but it comes about automatically, Bryce applies this, is that you get some reflection at grazing angles here across the edge of this surface. So the appearance of the glass is dependent on the bending property as it goes through the surface, and the reflection property that even though you don't think you've got it, it is there. You can persuade Bryce to switch the reflection off, and then you'll see how dependent the appearance is on reflection. But for the time being, we'll just apply this and I'll show you how it looks in our render. So you might notice that the shadow here looks rather curious with the bright and dark areas, and likewise here. I suppose it makes more sense here, and this is an attempt to simulate the effect of caustics. It's not entirely successful, and you might also notice that the render time is rather slow, and the reason for this is that the transparency, of course, allows the rays to travel through to things that are behind rather than stopping at the surface, and the result of the refraction as well, creating more complicated calculations, and the travelling through one surface to the next surface all slows the render time down. How many times the ray travels through the object is controlled by this maximum ray depth, which I've already set down at 4. Its default value is 6. If we turn it down to 1, for example, you'll see that the object gets darker because the ray stops at the first level, if you like, and then bit by bit you can modify this till you see that it goes through another level and then returns black. But every time it gets to the end, it returns fully black. So the higher value you have here, so I'll set it to the default value, and you'll load a scene, it's at 6. It means that your shape will look brighter, but that the render time will go up as a result of all the extra calculations, because it doesn't come to an end. Now, if we just go to the material, what I'm going to do now is put a blob in here and press the shift key and click on the name there, go to basic. I'll select basic slope will do, go into the deep texture editor, get alpha output for this, change this to sine, and just make sure that I'm providing a fully black alpha output here. And then by using this and turning the transparency right down, you can see I've effectively see I've turned off the reflection there. So now all you're seeing is as a result of the rays being bent within the material because of the refractive index. There is no reflection, and the specular highlight that's being generated as a result of the specular channel. So this, by turning different components off, you can see what the overall effect is made up of, and then you can determine how important that component is. And I think you can see by this that the reflection component is vital to the appearance of it being glass, and the refraction component is less vital. However, we do have an option to change it, and you can apply total internal reflection, and that will change the refraction properties. And now you see that we're getting a bit more light in this, and there's a bit more interest. So if we have total internal reflection applied, even though we don't have reflection on the surface geometry, you do get more of an effect of it being like a glass. I don't think there's any rendering overhead in turning that on, and you'll find that if you don't have it applied, things look more like plastics, and if you do have it applied, things look more like glass. Again, the appearance, though, is dependent on reflection, so we should really concentrate on reflection. And at the moment, what we're reflecting is just the standard Bryce sky. So what will happen if we incorporate a more complex background, much like metals, for it to reflect, then your materials will look more realistic. And if you use a HDRI image captured from the real world, such as those provided by Horo, then your materials will look again more realistic. Before we do that, we'll just go back into the material labs here and reset ourselves, and I'll point out that this specular highlight is there to simulate the bright light source of, well, the sun in this case. But if we're going to provide good quality reflections, we don't really need this. So I'm going to turn the specularity to 0, and then we'll have a look how it looks in our render. So we've lost that specular highlight, and the reflection looks a bit plain. Another advantage of HDRI images is, because the values captured in the HDRI image are so high, or can be so high, compared with the values displayed by a monitor, then while you look directly at the image, it may seem you're seeing all the information, but you're not, and additional information can be extracted through reflection. So providing a HDRI image for reflection will provide you with much more realistic effect of a real environment than it would if it was just a picture background. And that's a little bit hard to explain, and I've not done a very good job of that, so probably the best thing to do is load all in and I'll show you. So I'm going to load in one of Horo's HDRI images. Here we go. I'm going to apply it as a background and add it to the sky, reduce the quality. I'm going to set these values to 0 for now, so no specular output, no HDRI effect. I'll just turn the sun back on, and I'll switch on render in scene, and I'll increase the intensity to 10. So a few little modifications there, and then we'll nip out of here, and you can see we've got some nice reflections on the material surface now. And what I hope you can see is it's looking a lot more realistic. And the thing is, the thing that's difficult to appreciate is a HDRI background is not the same as providing just a spherical image as a background. No. And another thing I should point out is I've forgotten to set the sky to fully black, so the adding to sky is adding atmospheric effects. So if I just turn the atmosphere off and set it to fully black, you'll now see the result of the HDRI altogether. You'll see it looks a bit darker. We'll address that issue in a minute, but what I wanted to show you was it's not the same as having just a background image reflected. So I'm going to create a default Bryce sphere and enlarge that to encompass the entire scene, and then I'm going to use the option of exporting this background as a spherical image. So if I export this spherical, and it doesn't really matter what I call it, I'll just call it SM for spherical map, and save that, I now have stored a spherical map generated from the HDRI background. But this spherical map, when it's applied as a material in Bryce to a sphere, doesn't contain the HDRI information. This is only at the standard dynamic range, so the reflections, as you'll see, are not the same. Right, to get this right for mapping to a sphere, I need to just modify it slightly before I get too far down this road. So I load it in and I mirror it, and then I offset it to half its length, and then I'll just save that again. So that's the JPEG image. Now go back in here, check out of there, and go into the materials for this sphere that I've made to encompass the entire scene, and I'm going to use, well, I'm going to have it show up in the background, so I'll use ambient, give it the ambient color of the spherical map that I've just generated. There we go. Make sure it's applied spherical, and then light that up with global ambient, and make sure the sun can get through it by not casting any shadows. So now we've got a backdrop in the same place as the HDRI image was, but is just a picture, to demonstrate that the HDRI providing reflections for, well, metals or glasses is far superior than just providing a background. So I'll just check out of here now, set the global ambience up to fully white, and then render in scene, and you can see now that the highlights on this have lost a lot of their power. The reflection looks the same in the perfectly reflecting sphere I've got here, but because these reflections are generated through grazing angles, they attenuate the light values. The light values from the HDR image are higher than can be displayed on the monitor, so when they get attenuated they're still as bright as fully white at their brightest. But when we use a image mapped, just a bitmap image mapped to the background, then we're in a low dynamic range, and then the reflections lose their highlights. So I'll just get rid of that sphere now, and I'll re-render again so you can see the difference, and you'll see that everything was aligned as it should have been, but now we've got these super bright highlights on the surface which really make the material come to life. So I've covered now the importance of using a HDRI backdrop. One of the other limitations that I sort of touched upon was these shadow regions. They don't look very good. We can provide light from the HDRI. There is a drawback to that. It does increase render time, but we're dealing with the shadows now, so let's do that. So I'm going to disable the sun, goes fully dark, and then I'll give some HDRI effect, which is diffuse output from the 16 simulated light sources that I've got as a background. You can see things are looking improved here, so I'll just give that a quick render. Okay, render time still is not too bad, and the reason for this is that we don't have any diffuse output from the glass. If I was to put, I'll select my group here, some diffusion in here to lighten the material slightly, because it does look a little bit dark because of the property that we set here, total internal reflection, which improves its realism but does tend to trap the light in it. The render time has gone up to 3 minutes, and you can see it's a lot slower. And the other thing is that these shadows are still a bit distinct, so there's a couple of things there. So we'll get rid of the diffusion, and that reduces the amount of work we have to do, and we're back down to 8 seconds. But these shadows, not so good. We need to sort those out. So I'll show you a trick that Horror brought up in a previous video. If I set the shadow softness to 100 and we're in regular rendering mode, this is going to really increase the render time. So we're at 14 minutes now, and that's not really taking into account the anti-alias pass, which will be very slow when we come to render with regular rendering. However, if we switch over to premium options and select just 4 rays per pixel and soft shadows, we will get quite a lot of noise in the soft shadows, but it will be much more efficient. You see we're back down to 39 seconds now, and we've done something to disguise the issue we've got with the shadows having too sharp an edge. Again though, the glass still looks a little bit dark, so what I propose to do in this position is to add in some ambient output, because this won't have an impact on render time, but you need to do it very carefully. So I'm going to put in 2.5, which may not seem like a lot, but it should be enough just to take the edge off these very dark areas in the material. Possibly a bit too much there, so I'll take it down to 2 and see how that looks. Okay, but by the same token, you see, you don't want the glass to look too heavy, because when you reach the maximum ray depth, artificially you're getting full black put inside the material. So by having ambient, and because it goes through several layers, it tends to get added up, it will put a bit of lightness back in the glass, and even that might be a bit strong. So I say you've got to be quite careful with the amount of ambient you add in. I'll go for 1.5, and also bear in mind that the global ambient colour will determine the maximum levels. So because I turned it up to fully white when I did the background, then it was a bit higher. Originally when I tested this, I set it at 5, but I got the global ambient set at its default value, which was great. So having done that, and because we're using premium effects, you can always consider adding more premium effects in with a lower overhead. But bear in mind, if you start mixing transparency and true ambience, then you might have an alarming rise in render time, depending on, well, I'll just try it to show you. So if we do true ambience, scatter correction, we'll just leave it on scatter correction for this test. Now, let's see. Okay, lots of noise, and we're up to 20 seconds, so that's not really too bad. So that might be worth giving that a try, but you've got to consider, you know, if we take it up a higher level and to mitigate the noise, we're up to 3 minutes 16, and then you might want to experiment with obscure lighting. We're getting a bit off topic here, so I'll just turn that off for now. We might come back to that in a later video, because I can see it's going to be quite an involved topic. So we'll see what level we can set for the ground, for the shadows, that we think we can get away with noise wise, because that's going to be the critical thing. So we're at 3 minutes 4 now, and this is still quite noisy. You could always filter it in post work, but I know some people don't really like that idea. The other thing to do is to change the material on the ground so it's got a pattern or bump to disguise this noise or something along those lines. But if you didn't want to go down that route, then you'd have to turn it up and then try and render again and see what the noise level's like. So it's not too bad. Let's see what the render time is. It's going to probably about 6 minutes looking at that. Yeah, 6 minutes 48. So let's try 64. So that's going to double the render time. So that will take us up to probably 20 minutes. Mind you, I've got Camtasia running in the background, so that makes a difference. So I suppose I should recap at this point. I'll let this render out and you can see what it looks like. I'll put it on the first frame of the video. You want to take your standard glass, and if you're going to use a HDRI background that's got some nice bright highlights in it, you get rid of the specular effect. You can light it with your standard Bryce sun, but if you're using complex models like this, then you'll have problems with the shadows unless you can change the ground so they don't show up so much. Otherwise, provide diffuse output only from your HDRI image, then you won't be stimulating any specular in the material, if there is any, and take advantage of premium rendering soft shadows. Remember, you've got to turn it on in the render engine render options and provide that control in the image-based lighting lab to get the effect working. It's no good turning it on in image-based lighting, but it won't work in premium until it's been checked on there. As I say, we'll come back to this topic later on in more videos because it's really quite involved and there's a lot of things I've not even mentioned yet, and I'll also probably have a go at setting up some glass within a obscure lighting setup because we're already using the premium effects. Probably try something with depth of field as well, but for the time being I think I've given you enough to get your teeth into now, so I hope you found that interesting and useful, and it will help you render more realistic glass materials in your own scenes.